In this video, we're going to discuss how you can solve systems of equations algebraically using elimination by addition. Let's look at an example. X plus 2y is equal to 6, and the other equation is 3x minus 2y is equal to 12. The goal when we're solving a system of equations algebraically is we want to be able to write a new equation using the information that we know from the system of equations. We want to be able to write this new equation that only has one variable. Now notice that if we would add these two equations together, we would add the x terms. X plus 3x is 4x. Positive 2y minus 2y, those two terms cancel out. And this is equal to 6 plus 12, which is 18. Since we have this special type of system of equations where we have a term that's going to fall out, one of our variables will fall out when we add the equations, we can add the equations like that and then solve this new equation for the variable that we still have. So now we have the x-coordinate of this point of intersection of these two equations. Let's solve for the y-coordinate. To do that, we could just substitute whatever we got for x back into one of the equations. Doesn't matter which one. Let's just use the first one. And we're going to solve for y. Now for x, we have 9 over 2, minus 9 over 2, and minus 9 over 2. 2y is equal to 6 minus 9 over 2, which is 3 over 2. And we're going to divide by 2 and divide by 2. Y is equal to 3 over 2 divided by 2, which is 3 over 4. So the point of intersection of these two lines is x is equal to 9 over 2 and y is equal to 3 over 4. Let's look at another example where we can use elimination by addition. 4x minus 7y is equal to 10, and x minus y is equal to 1. And we want to solve this using elimination by addition. We could also solve it using substitution, but we want to solve it using elimination by addition. But let's say we would add these two equations now. We would have 4x plus x is 5x, negative 7y minus y is negative 8y, and 10 plus 1 is 11. We didn't really accomplish anything when we added these two equations because we're still left with both of these both variables. We still have an x and we still have a y. The point of doing elimination by addition is so we can cancel out one of our variables. So it's not going to work. How can we make it work? If we somehow rewrite our one of the equations so that it'll cause one of the variables to fall out. Let's say we would multiply this whole equation by negative 4. We're allowed to do that because as long as we multiply every single term in the equation by the same number, we aren't changing the value of the equation. So we're going to distribute the negative 4 over the x, over the negative y, and over the positive 1. This equation becomes negative 4x plus 4y is equal to negative 4. And now let's say we would add these two equations. The first one is 4x minus 7y is equal to 10, and the second one is negative 4x plus 4y is equal to negative 4. And we're going to add these two equations. 4x minus 4x, now those two cancel out. Negative 7y plus 4y is negative 3y. 10 minus 4 is 6. That caused the x's to cancel out and we're left with an equation with just y. Divide by negative 3 and divide by negative 3. Y is equal to negative 2. That's the y-coordinate. Let's solve for the x-coordinate. We can do that by plugging in into either of the equations for y and solving for x. 4x minus 7y is equal to 10. We'll use the first equation. 4x minus 7 times y we know is negative 2 is equal to 10. 4x, negative 7 times negative 2 is positive 14. It's equal to 10. Minus 14 and minus 14. 4x is equal to 10 minus 14, which is negative 4. divide by 4, and divide by 4, x is equal to negative 1. So the coordinate of the intersection of these two lines is negative 1 comma negative 2. So what the goal when you want to do elimination by addition, the goal is to have one of your variables in each of the equations in such a way that when you add the two equations, one of the variables will fall out. In order to do that, you might need to multiply the whole equation by something. And it doesn't matter, we could have multiplied the second equation by negative 7, and then the y's would have fallen out. It doesn't matter. The goal is to have let's say we have a positive 4x in the first equation, we need to have a negative of the same coefficient in the second equation. If we have a negative 7y in the first equation, we need to have a positive 7y in the second equation for the y to cancel out. Let's look at another example. 2x minus 4y is equal to 7, and 3x plus 3y is equal to 8. So let's say we would add these two equations now. We want to do elimination by addition. If we would add these two equations, we would get 2x plus 3x is 5x, negative 4y plus 3y is negative y, 7 plus 8 is 15. That doesn't really help us because we still have both of our variables. The point of doing elimination by addition is so we can cancel out one of our variables. To use elimination by addition to solve this system of equations, we're going to need to multiply either one or both of the equations by some number so that we can have them in a form that one of the variables will fall out when we add them. The coefficient of x in the first equation is positive 2. In order for the x to fall out when we would add it to the second equation, we would have to have the coefficient of the x in the second equation being negative 2. But since it's already 3, it's not possible for us to get the coefficient of x in that equation to be equal to 2. And likewise, there's no way we can get the coefficient of the x in the first equation to be equal to negative 3. For the y's, we have a negative 4y and a positive 3y. There's no way that we can change the negative 4y into a negative 3y, and there's no way that we could change the positive 3y into positive 4y. So there's nothing we can multiply by either of the equations easily to be able to use elimination by addition. But let's say we multiply the first equation by negative 3 and the second equation by positive 2. Then we have for the first equation, we have to make sure we distribute it over all of the terms, even the constant on the other side. Because if we multiply the same thing by every term in the equation, we aren't changing the value. Negative 3 times 2x is negative 6x. Negative 3 times negative 4y is positive 12y. Negative 3 times 7 is negative 21. And the other one, 2 times 3x is 6x. 2 times 3y is 6y. 2 times 8 is 16. Now when we add these two equations, the x's fall out. Negative 6x plus 6x is 0. 12y plus 6y is 18y. Negative 21 plus 16 is negative 5. And we could solve for y by dividing by 18 and dividing by 18. Y is equal to negative 5 over 18. That's the y coordinate of the intersection of these two lines. Let's solve for the x coordinate. To do that, we just have to plug in this y that we found into either of the equations. Let's use the first equation. 2x minus 4y is equal to 7. We could use the equation that we changed it into, this one over here. But we could also just use the original, it doesn't matter. Let's use the original. 2x minus 4 times y, we already know is negative 5 over 18, is equal to 7. So 2x, let's do negative 4 times negative 5 over 18 is 10 over 9 plus 10 over 9 is equal to 7, and let's solve this for x. Minus 10 over 9, minus 10 over 9. 2x is equal to 7 minus 10 over 9, which is equal to 53 over 9. Divide by 2 and divide by 2. X is equal to 53 over 9 divided by 2. which is 53 over 18. That would be the x-coordinate of the intersection of these two lines. So the point where these two lines intersect is 53 over 18, comma, negative 5 over 18. So notice what we did in order to solve this equation. We multiplied both equations. We multiplied them by different things, but we multiplied each equation by something so that we would be able to rewrite the equations in such a way that one of the variables would fall out when we added the two equations. And that's always going to be the goal of elimination by addition, to have one of the variables fall out when we add the two equations. Now, we could also have rewritten these equations in such a way that y would fall out. If we would multiply the first equation by positive 3 and the second equation by positive 4, then the coefficient of the y in the first equation would have been negative 12, and the coefficient of the y in the second equation would have been positive 12, and the y's would have fallen out. You would have gotten the same answer for x, and you would have plugged in for y.